Alright, well, welcome back. Thank you for watching this review video. This will help you get you ready for the math, so when we're ready to get started, you will not be completely lost. So when you see these problems, write them down, show them in your notebook tomorrow. I will give you some extra credit. Here we go. First problems we're going to do to review are distributing, combining like terms, and then solving an equation with variables on both sides. I'm sorry about the pen batteries ran out. I have to do these problems using my clicker, so it's a little bit harder to follow, but hopefully you'll be able to see. So this first problem here, first step to do is to distribute. I'm taking that 3 and timesing by both things inside there. 3 times x will give me 3x. 3 times negative 2 gives me negative 6. I bring down the negative and the 12. Opposite now here of subtracting 6 is adding 6. So at this point, after I distribute, I'm doing inverse operations. I'm doing the same math to both sides. So the opposite of subtracting 6, adding 6. Do that to both sides. Bring down that 3x, bring down my equal. Negative 12 and 6 give me negative 6. Right here is 3 times x. The opposite of timesing 3 is dividing by 3. So I'll divide both sides by 3 right there, and that will give me x by itself and gives me x equal to negative 2, because negative 6 divided by 3 is negative 2. So hopefully at this point you're okay with your adding, subtracting negative rules, negative 12 and 6, and you're okay with your dividing and multiplying, dividing rules for negative, positive numbers. And remember, these rules are crucial. Next step here, I'm going to show you how to check it. I'm taking that answer, negative 2, and I'm going to plug it in right here and show you that that is a true solution. So I'll take that negative 2, plug it in. Everything stays the same. Only where that x is will I be plugging in that number. So right here, I'm going to plug in a negative 2 right where that x used to be. So right here, negative 2. The rest of the problem is exactly the same. Negative 2, the parentheses, the equal, the negative 12. Right here, I'm going to, instead of distributing, which I could do, I'm going to do inverse operation, or I'm going to do order of operations, which has me do this math on the inside first. Usually when you have just plain numbers right here, you do order of operations, parentheses first, multiplying second. When you have a variable, then you distribute. So that's when you know to distribute, and then you know the opposite, or you know to do operations. All right, so here we go. So that gives me negative 12 right there. 3 times that negative 4, which I get by combining those two negative 2's. And then that 3 times negative 4 does give me negative 12. So that shows that that check does prove that x equal negative 2 is a solution. All right, next problem here. Before I do any inverse operations, I combine all like terms. So I'm going to combine my x terms, and I'm going to combine my plain numbers there. So 4x minus 8x gives me negative 4x. Negative 2 plus 6 gives me positive 4. I have my equal, I have my 16. And then now I could start my inverse operations. Now I start by looking at what can get x by myself, which is get rid of this 4 first by adding, subtracting, and then dividing last. So first step, first inverse operation, subtract 4 on both sides. Those cancel away, bring down the negative 4x, bring down my equal. 16 minus 4 is 14, or I'm sorry, 12. Then right here, be careful, I'm not going to add 4 to both sides. This is negative 4 times x. The opposite of multiplying by negative 4 is dividing by negative 4. So make sure you don't just divide by 4, but by negative 4, which cancels away. Gives me x by itself, which is negative 3. So again, if I took that negative 3 and I were to plug that in here and here, it would give me 16 if you did the math correctly. All right, last problem to review. Basic equations, variables on both sides. So I'm going to start by adding the plain number, getting rid of the number on the left, and then I'm going to go to the right and get rid of the x term, and then I'm going to go back to the left and divide. So here we go. First step, get rid of that plain number on the left side there by adding 2. That brings down the 4x and the equal and the 6x. Negative 12 plus 2 is negative 10. So again, hopefully you know your negative rules at this point. Now I go to the right side and get rid of that 6x by subtracting it. So now I'm getting rid of that x term. I'm not doing any division yet. Get rid of that. 6x, 6x. 4x minus 6x gives me negative 2x. So it follows the same rules for integers. Gives me equal to negative 10. And then right there, the last step coming back to my left side there, I do my division. So I divide both sides by negative 2. Cancels away and gives me x by itself. And then negative 10 divided by negative 2 is positive 5. And again, if I took that 5 and I plugged it in here, would give me 20. 20 minus 2 is 18. If I took that 5 right here, it gave me 30. 30 minus 12 is also 18. So 5 does work. Sorry, so here we go. Next kind of problems are literal equations where you're solving for more, or an equation with more than one variable. You're solving for a specific variable. So this first problem here, solving for y. Get rid of that x term first. So I'm subtracting it. Getting rid of 2x, subtracting on both sides, goes away. Be careful not to combine unlike terms here. You cannot combine these. So you just write them next to each other. Bring the 2y down and the equal. And I'm going to write this with the x term first. So negative 2x, bring down the negative 10. Then right there, I divide both sides by 2. Remembering that that 2 divides into both terms there. It divides into the negative 2 and the negative 10 separately. So if I split it up into negative 2x divided by its 2, and then minus 10 divided by its own 2, will give me the simplified answer as y equals negative x minus 5, or negative 1x minus 5. For again, if we're graphing that, negative 5 would be the y-intercept, the point 0, negative 5. Negative 1 is the slope, or the rate of change, or the d number, over 1, down 1, over 1, down 1. All right, next problem. I'm solving this one for x instead. So again, when you're doing these, always look to see if there's any terms you could add or subtract on either side. Here, I'm going to get rid of this term by adding it, and then look to do any division. So I'm adding this term to both sides, making sure I do not combine unlike terms there, because 20 and 2y are unlike terms. Bring down the 5ax. I'm going to write the 2y first and the 20 second. Does not matter the order you write that. You can write the 20 first if you wanted to. My next step is to divide everything by 5a. I'm going to do this in one step here. I'm trying to get that x by itself. The opposite of multiplying by 5 and multiplying by a, the opposite of timesing by 5a, is dividing both sides by 5a. So I'm going to divide both sides by 5a. That will cancel away everything on that left side and leave x by itself. And then over here, if I split it up, the 2y over 5a does not really simplify, so I'm going to leave that alone. But 20 over 5a, 20 divided by 5 gives me 4. And then I know it's a little tricky, but you need to leave that a on the bottom. That a does not come to the top because it was still on the bottom there. So even though 5 and 20 divide and give you 4, that a stays on the bottom. I know that's a little tricky there, but I have faith in you guys. And here I'm trying to show you again why 20 over 5a gives me 4, and then that a stays on the bottom. All right. Last problems. Inequalities, and then writing the answers in a couple of ways. So here I'm solving this inequality just like I would a regular equation, but it has an inequality symbol here. That is negative 2x plus 4 is less than, remember the inequality that looks most like an L, less than is that way. So again, to solve this, first step, inverse operation, I'm subtracting 4 on both sides. Bring down the negative 2x. Do not write an equation. Don't write an equal right there. Write an inequality. 10 minus 4 is 6. Right here, dividing both sides by negative 2. Remember, dividing inequalities by negative 2 switches that inequality around. So again, it's not going to be less than anymore. My answer is going to switch to x is more than, and then that answer is negative 3, because 6 divided by negative 2 is negative 3. Here on my number line, remember 0 in the middle, 3 positive on the right. I'm going to do 3 negative on the left. that's going to be an open circle because that inequality is plain old more than. It's not more than or equal to, so more than, open circle. Shade the arrow to the right. More than is always off to the right. Interval notation has you write a rounded bracket on -3 because it's open circle, and has you do comma positive infinity because it's going off to the right, and then another rounded circle there, or bracket. Set notation has you always write that big fancy squiggly and then X and that little line, and then X is an element of the real numbers, so you always do that for these inequalities. And then in the roll comma, and then now you write an inequality that matches that. So X is more than -3, or always the same exact inequality you get in your answer here for set notation. This problem right here, this compound here, I'm going to do the same inverse operation to all three parts. These compound inequalities, they always open to the left here in this direction. These OR ones always open like this towards each other. So again, you might want to try to recognize that pattern there. So here I'm going to subtract 2 on all three parts. 2's in the middle go away. -10 and -2 give me -12. Bring down my inequality and the 2x. Bring down this less than or equal to, and then that gives me 4. Divide everything by +2. I'm not going to switch anything because I'm not dividing by -2 there, so that inequality stays the less than direction there, and then the less than or equal to direction right there, and equal to 2. So that answer is -6 is more than, or X is more than -6 and less than or equal to -2. So that means the answer is a shaded section sandwiched between 2 and -6, where -6 is open circle because of the inequality here, and -2 gets the closed circle. And again, sorry about that. And then shade that intersection. Interval notation goes from rounded bracket -6 to comma square bracket on that 2 because that's a inequality that's less than or equal to. And sorry, that is rounded right there and square. Set notation always has the same parts. The X is an element of the real numbers, and then you write that inequality in there, -6, X in the middle, and then the inequality less than or equal to 2. All right. Last one, this compound OR one, always the inequality open that way towards each other. So I'm solving these both separate. First answer is X is less than 2. The other answer when I solve that, adding 2 to both sides, gives me X is more than 7. So that answer is X is less than 2 or X is more than 7. That always has a look of the arrows shooting off from each other. So here we go. So 0, I'm going to put 2 on the right side of 0, which it should be, and 7 a little bit more spaced out. It's going to be open circle on both because the inequalities themselves, they don't have that equal line under them. So open circle shaded to the right on 7, open circle shaded to the left on 2. And if I wrote that interval notation, I would have a 2, one with a little union symbol, so rounded -infinity because that arrow is going to the left. 2 rounded, union symbol, 7 rounded because the inequality, comma positive infinity rounded. Set notation again, you use the same squiggly symbol, and X is an element of the real numbers, and then you write your 2 inequalities in there. So X is less than 2 or X is more than 7, and you do put that or in there. And there we go. So for tomorrow, write these down, show them in your notebook, don't tear them out, leave them in your notebook so you can study them, and I will give you some extra credit. Good luck. See you tomorrow.